All right, diving in today, folks, we're tackling software testing, a topic I'm sure many of you deal with on a daily basis. We're dissecting software testing strategies.pdf, a dense document but packed with insights. Our goal is to make this complex world a little less mysterious.
Yeah, exactly. Think of this as your masterclass in software testing, breaking down those methodologies, those challenges, and those all-important solutions that ensure quality in today's tech landscape. We're going depth, folks, covering everything from the basics to the really cutting-edge stuff. Different types of testing, hurdles you hit in development, even how AI is changing the game.
So the goal is to equip everyone listening with a solid understanding of how we guarantee that software is reliable, right? In this day and age, it's pretty crucial.
Absolutely. The sheer amount of software we interact with every single day. It's mind-boggling, and it all has to work flawlessly. So where do we start? Well, any deep dive into testing needs to start with the foundations.
Okay, back to basics. What are the fundamental approaches to testing software?
So you've got two main categories: white box testing and black box testing. Think of white box testing as peeking under the hood.
So you're actually looking at the code itself.
Exactly. You're examining the internal logic, the structure, how it's all implemented. Our document uses the example of path testing to illustrate this. Imagine you have a Python function, something like calculated discount. You've got price, quantity, maybe discounts, and free shipping offers. There are a bunch of different ways that function could execute, right?
So based on the inputs, the code could branch off in different directions.
Precisely. You might buy a small quantity, no discount. Or maybe you buy a ton and qualify for a discount. Or maybe your total pushes you over the free shipping threshold. Path testing is about systematically going through each of those possibilities, ensuring the code handles each scenario correctly.
So in essence, you're mapping out every possible route through the code and making sure it behaves as expected. The document also mentions branch testing. How does that fit in?
Well, branch testing zooms in on those decision points in the code, every if statement, every loop. The goal is to make sure you test both the true and false outcomes of those decisions. It gets even more intricate with condition testing, where you look at the specific conditions within those decision points. And then as your code base grows, you have decision testing and multiple decision testing, making sure you've covered all the bases as the complexity of your code increases.
It sounds incredibly detailed, and I can imagine, as software gets more complex, this kind of white box testing could become quite a challenge.
Oh, absolutely. Now, on the flip side, we have black box testing. Here, you're testing the software without any knowledge of the underlying code. It's all about how the software behaves from the outside, just like a user would experience it.
So you're essentially putting on the user's hat and seeing if the software delivers on its promises.
Exactly. One common technique here is equivalence partitioning. You take all the possible inputs and divide them into groups or classes. The idea is that inputs within a class should be treated the same way by the software.
Right, so you don't have to test every single possible input, just a representative sample from each group.
Exactly. Saves a lot of time. But the trick is accurately defining those equivalence classes. Like, imagine you have different shipping options based on order value, destination, and membership status. Lots of variables, and figuring out the right groupings can be tricky.
Sounds like it requires a lot of thought. What are some of the other black box testing strategies?
Well, another one is boundary value analysis. It's about testing at the edges of those input ranges. Imagine a password has to be between 8 and 20 characters. You'd test with exactly 8, exactly 20, but also 7 and 21 characters to see how the system handles those edge cases.
Clever. I guess those edge cases are where things often break down.
Exactly. Now, decision table testing is really useful when you have lots of conditions that could lead to different actions. Again, think of shipping options, order value, destination, membership. All these factors can result in different outcomes. Decision tables help you map out and test every single combination.
It's all about being systematic, making sure you haven't missed any crucial scenarios.
Precisely. And then, of course, you've got use case testing, where you're walking through scenarios a user might encounter. Think of the e-commerce checkout process. You'd test a registered user adding items to their cart, applying a coupon, maybe trying different payment methods. And of course, you'd want to test both the happy path, where everything works perfectly, and also those negative scenarios, like using an expired coupon or having insufficient funds.
So you're essentially simulating the real world,
Right.
throwing all sorts of situations at the software to see how it handles them.
Exactly. Pairwise testing is another interesting technique, focusing on interactions between pairs of input parameters. Often, the majority of bugs pop up because of how two inputs work together. So you test all those pairings rather than every single possible combination. Could save you a ton of time.
Makes sense. Efficiency is key in software testing.
Right. Definitely. And we can't forget about error guessing. This is where the tester's experience really comes in handy. They use their intuition and knowledge of common pitfalls to anticipate potential errors. Finally, you've got exploratory testing, which is much more freeform. Testers are simultaneously designing and executing tests, adapting their strategy based on what they find along the way.
It sounds a bit like detective work, sniffing out those hidden bugs and usability issues.
Absolutely. Now, moving beyond these fundamental testing approaches, the document also talks about the difference between functional and non-functional testing.
Okay, so functional testing is all about whether the software does what it's supposed to do, right?
Exactly. Does it deliver on those specified requirements? And within functional testing, you have different levels. Unit testing is all about testing those individual components in isolation.
So, like making sure each individual piece of the puzzle works correctly.
Precisely. And the document highlights how these unit tests can also serve as documentation, which is pretty neat. Then you move up to integration testing, where you're looking at how those different pieces fit together, how those modules interact.
Ah, so you're making sure those puzzle pieces actually form the intended picture when you put them together.
Exactly. And then, of course, you have system testing, where you're testing the entire integrated system as a whole. And finally, there's acceptance testing, making sure the software meets the needs of the users and the business. This often includes user acceptance testing, or UAT, getting real users involved to see if it meets their expectations.
That sounds crucial. Ultimately, it's the users who will be interacting with the software, right?
Absolutely. Their feedback is invaluable.
Okay.
And you also have business acceptance testing, or BAT, making sure the software aligns with those initial business requirements.
So it's a multi-layered approach, ensuring quality at every level, from individual components to the whole system and the end-user experience.
Yeah.
Now, what about non-functional testing? What aspects does that cover?
Non-functional testing focuses on the software's quality attributes that go beyond specific functions. How well does it perform? How reliable is it? How easy is it to use? This includes performance testing. How does the software hold up under different loads and stress levels? Reliability testing, can it run for extended periods without failing? Usability testing, how intuitive is the interface for users?
So it's not just about doing the right things, but doing them well, efficiently, and in a way that users find pleasant.
Exactly. And then you also have compatibility testing. Does the software work across different operating systems, browsers, devices? And compliance testing, ensuring the software meets all the relevant industry standards and regulations.
So there's a whole world of testing beyond just making sure the features work as intended.
Absolutely. Now, the document also mentions specialized testing, which covers those specific scenarios or specific stages of development. You have alpha testing, where the development team or internal users test the software before it's released to the wider public.
An early check within a controlled environment.
Yeah. Then you have beta testing, releasing a nearly finished version to a limited number of external users to get their feedback. It's a great way to catch those real-world issues that you might not have anticipated.
Real users, real feedback. Invaluable.
Absolutely. And then you've got regression testing. This is essential after any code changes. You want to make sure those changes haven't introduced new bugs or broken existing functionality. And automation is key here, running those regression tests quickly and efficiently.
So every time you tweak something, you make sure you haven't inadvertently messed something else up.
Precisely. And lastly, there's smoke testing. A quick set of tests to make sure the most critical functions are working, that the build is stable enough to proceed with more in-depth testing. It's like that initial sanity check.
So it's a multifaceted approach to testing, covering all those different angles and stages of development. Now, the document also emphasizes testing throughout the entire software development lifecycle. So it's not just a phase at the end, right?
Absolutely not. Testing needs to be woven into the fabric of the entire process. It starts right from the requirements phase. Getting testers involved early helps identify potential problems with the requirements themselves, ambiguities or inconsistencies that could cause issues down the line.
So it's about prevention rather than just detection.
Exactly. Catching those issues early can save a lot of headaches later. And during this phase, you can also start creating traceability matrices, linking each requirement to specific test cases.
Ensuring every requirement is thoroughly tested.
Exactly. Then in the design phase, testers can evaluate the architecture, look for potential testability challenges, and start thinking about the types of testing that will be needed. And during the implementation or coding phase, developers themselves can start writing unit tests to verify their code.
So it's a shared responsibility, with both developers and testers working together to build quality in from the start.
Precisely. And then, of course, you have the dedicated testing phase, where the focus shifts to integration testing, making sure all those components work together seamlessly. And interface testing, verifying the interactions between different systems, is also crucial during this phase.
So you're putting those pieces together and making sure the whole system flows smoothly.
Exactly. And managing the test data, creating realistic test scenarios, masking sensitive data, that's also a big part of this phase. And setting up the test environment, making sure it mirrors the production environment as closely as possible is absolutely crucial.
So you're trying to replicate those real-world conditions as much as possible.
Exactly. You want to be confident that the software will perform as expected when it's released. And then, even after deployment, testing doesn't stop. You've got pre-release testing, making sure everything's configured correctly, data migration is successful, backup and recovery systems are in place. And those rollback procedures, having a plan B in case something goes wrong during deployment, those are crucial.
That's a lot to think about.
It is. And even after the software is live, there's still a role for testing. Monitoring the application in the real world, identifying and fixing any issues that crop up, collaborating between the development, operations, and testing teams. It's an ongoing process.
So it's a continuous cycle of testing, validation, and monitoring. It never really ends.
Exactly. Now let's move on to some of those advanced testing concepts the document covers. Test environment management. This is huge in today's complex IT landscapes.
But what makes it so challenging?
Well, think about all the different hardware, software, network configurations that need to be managed and kept consistent across all these test environments. Configuration management is key, making sure everything is documented and can be reproduced consistently.
Because if your test environments aren't accurate, your test results aren't reliable.
Precisely. And the document highlights how achieving and maintaining that consistency across different teams and different projects can be a real challenge. Modular design can help, breaking down the environment into smaller, manageable components.
So like building blocks that can be swapped or updated without affecting the whole system.
Exactly. And then, of course, you have virtualization and containerization, technologies that have revolutionized how we create and manage test environments.
Okay, break those down for me.
So virtualization is like creating virtual versions of hardware, operating systems, storage, networks. You can run multiple isolated operating systems and applications on a single physical machine.
Makes things more efficient.
Definitely. And containerization is a bit lighter. You're packaging the application and all its dependencies into a container that can run consistently across different infrastructures.
So like a self-contained unit that's portable and predictable.
Exactly. The choice between virtualization and containerization often depends on how much isolation you need, your scalability requirements, and how efficiently you want to use resources.
And the document also mentions the challenges of deploying and managing large-scale test environments.
Oh, yes, it can be a huge undertaking. You've got to plan your infrastructure carefully, make sure you have enough hardware, network capacity, and storage. You might need to run tests in parallel to save time. Managing the configuration of all those different environments, generating the massive amounts of test data you might need, dealing with all those dependencies between components, and making sure everything is monitored effectively. It's a complex orchestration effort.
Sounds like you need a whole team just to manage the test environment.
Sometimes it feels that way. And then you've got the option of using cloud-based test environments, which can offer a lot of flexibility and scalability.
Right, the cloud. What are the advantages and challenges there?
The big pluses are scalability and cost effectiveness. You can spin up resources as needed and only pay for what you use. But of course, there are challenges. Managing those cloud costs effectively, making sure your data is secure in the cloud, dealing with potential latency or connectivity issues, those are things to consider.
Let's talk about performance tuning and optimization. It's not just about making the software work, it's about making it work smoothly and efficiently, right?
Exactly. You need to make sure the software is responsive, can handle the expected load, and doesn't waste resources. And it starts with really rigorous performance testing. You're not just simulating typical usage, you're pushing the system to its limits.
So you're really stressing it out to see where it breaks down.
Exactly. You've got stress testing to see how much it can handle before it fails, spike testing to see how it reacts to sudden surges in traffic, soak testing, running it for extended periods to check for memory leaks or other resource issues. And then you have failover testing, simulating hardware or software failures to make sure the system can recover gracefully.
So a lot of different ways to put the software through its paces.
Absolutely. And once you've run those tests, you need to dig into the results, identify any bottlenecks, and figure out what's causing those slowdowns. That's where profiling comes in.
Profile.
Yeah, think of it as getting a detailed report card on how your software is performing under pressure. You can analyze the code itself, see which functions are taking up the most time or resources, identify memory leaks. You can also look at the system level, how the operating system is handling things, CPU usage, disk activity, network traffic.
So you're looking for those areas that need optimization.
Exactly. And then the document goes into strategies for making the testing process itself more efficient. You can parallelize tests, running multiple tests concurrently to save time. You can be selective about which tests you run, prioritizing the most critical ones or focusing on areas that have recently changed. And, of course, efficient test data management and optimization of the test environment can significantly speed things up.
And what about making the software itself more scalable?
Well, that's where scalability testing comes in. You want to make sure the software can handle increasing workloads as the user base grows or the data volume expands.
You're simulating growth, seeing how the software handles it.
Precisely. And you can scale vertically, adding more resources to a single server, or horizontally, adding more servers to distribute the load. Elasticity testing is also crucial, making sure the system can automatically adjust its resources based on demand.
So the software scales itself up or down as gated.
Exactly. And then for web applications and distributed systems, you've got to think about database scaling and network scaling as well, making sure the entire infrastructure can handle growth.
Let's move on to testing in agile environments. How has agile development changed the way we approach testing?
Agile testing is all about integrating testing activities throughout the entire development lifecycle, working closely with developers and other stakeholders in cross-functional teams. It's about rapid feedback loops, continuous integration, and continuous testing.
Continuous integration and continuous testing, those terms get thrown around a lot these days. Can you break them down for us?
Sure. Continuous integration, or CI, is all about frequently merging code changes from different developers into a shared repository. And after each merge, you automatically build and test the software. This helps to catch integration issues early on.
So you're constantly building and testing, making sure everything is working together as it should.
Exactly. And continuous testing extends this, running automated tests at various stages of the development pipeline. It gives you that instant feedback on the quality of the code. The document even lists some popular tools that support these CI/CD pipelines like Jenkins, GitLab CI/CD, Circle CI, and others.
Automation is key in this fast-paced agile world.
Absolutely. You need to automate those repetitive tasks, those unit tests, integration tests, regression tests, to keep up with the speed of development. And having a robust test automation infrastructure is crucial, selecting the right tools and making sure those tests are maintainable as the software evolves.
But it's not all about automation, right?
Mm-hmm.
Humans still play a critical role.
Definitely. Automation can't replace the human touch entirely. Exploratory testing, where testers use their creativity and intuition to find those unexpected issues, that's still incredibly valuable in Agile. And usability testing, understanding the user experience, that requires a human perspective. It's about finding the right balance between human and machine.
Now let's talk about data-driven testing, making decisions based on metrics and hard evidence, rather than gut feeling. What are the benefits of this approach?
It's about bringing objectivity and clarity to the testing process. You're using data to justify your decisions, to prioritize your efforts, and to demonstrate the value of testing.
So you're making the case for testing with concrete evidence.
Exactly. And there are a lot of powerful data analytics techniques you can use. You can analyze defect density, see which areas of the code are more prone to bugs. You can track test coverage, how much the application has been tested. You can look at test execution time, resource utilization, see where you can optimize the testing process itself. Regression analysis can help you understand how code changes are impacting performance. And you can even use predictive analytics to anticipate potential risks or defect trends based on historical data.
A lot of tools in the arsenal. And what about the role of machine learning in this data-driven world?
Oh, machine learning is a game changer. It can help us identify patterns and anomalies in all that test data that humans might miss. It can spot subtle trends and defect occurrences. It can even help us optimize our test automation efforts, suggesting which tests are most likely to fail based on past data.
So we're leveraging AI to make our testing smarter and more efficient.
Exactly. And the document also mentions real-time dashboards for monitoring all these testing metrics.
Why are dashboards so important?
They provide that instant visibility into the state of your testing efforts. You can see pass-fail rates, defect counts, test coverage trends, all in real time. It helps teams stay on top of things and address any issues quickly.
So, like a health check for your software.
Precisely. And of course, being able to communicate all this complex data effectively is crucial. You need to tailor your communication style to your audience. Technical teams want the raw data, the detailed analysis. Business stakeholders want the high-level summaries, the impact on release schedules. Visualizing the data through charts and graphs helps to make it more understandable. And crafting those data narratives, telling a story with the data, can be a powerful way to communicate the value of testing.
Bringing those numbers to life. And finally, the document touches on the legal and compliance aspects of data-driven testing. We can't ignore those, right?
Definitely not. When you're dealing with user data, especially sensitive personal information, you need to be extremely careful. You have to comply with all the relevant privacy laws and regulations. You need to make sure the data is anonymized and protected. You need secure testing environments. Transparency with users is essential.
So ethical considerations are paramount.
Absolutely. Let's dive deeper into testing throughout the software development lifecycle. We've touched on it, but the document goes into a lot of detail here.
Break it down for us.
So starting with requirements, as we said, early tester involvement is key. Identify those potential issues, those ambiguities right from the start, and establish that traceability, linking requirements to test cases. During the design phase, testers collaborate with developers, evaluating the architecture, considering testability. During implementation, the focus is on developer-driven testing, those unit tests, adherence to coding standards.
So everyone plays a role in ensuring quality.
Exactly. And then, of course, during the dedicated testing phase, you have integration testing, interface testing, test data management, setting up those realistic test environments. It's where a lot of the heavy lifting happens. During deployment, you've got that pre-release testing, verifying configurations. Release phase, it's about continuous monitoring, rapid issue resolution, and ongoing collaboration.
So testing is a thread that runs through the entire lifecycle.
Absolutely. Now, the document also discusses risk mitigation through testing. It's about identifying those potential problems early on and using testing to prevent them from becoming major issues.
What kind of risks are we talking about?
Well, you've got scalability risks, what happens when the system grows, maintainability risks, how easy is it to make changes to the code without introducing new bugs, compatibility risks, how well does the software play with other systems, and the testing phase itself can introduce risks, like insufficient test coverage or delays in testing, data migration, moving data from one system to another, that can be risky too.
And how does testing help to mitigate these risks?
So for scalability, you've got performance and load testing, pushing the system to its limits to see how it handles growth. For maintainability, you focus on testing the modularity of the code, making sure changes in one area don't break things elsewhere. For compatibility, you do a lot of integration and compatibility testing with different systems, different environments. And the document even provides case studies, real-world examples of how testing was used to prevent those big problems.
Okay, let's talk test strategy formulation. What goes into creating a comprehensive plan for testing a software project?
Well, first, you need to define those objectives. What are you trying to achieve with testing? What's the scope of testing? What needs to be tested? Then you choose the right testing types and methods, those white box and black box techniques we talked about earlier, functional and non-functional testing. Setting up the right test environment is crucial. You need to plan your resources, people, tools, infrastructure. You define your test deliverables, test plans, test cases, test data. You set a realistic schedule, establish clear criteria for test execution, and make sure everyone involved is communicating effectively. And of course, you build in those continuous improvement mechanisms, always looking for ways to make the testing process better.
It sounds like a lot to coordinate.
It can be, but it's essential. Now let's delve into some of those advanced test design techniques. The document covers some interesting concepts here. Model-based testing, for example, involves creating models of the system and then using those models to automatically generate test cases.
So you're abstracting the system and using that abstraction to create tests.
Exactly. It can be particularly useful for complex systems with lots of different states and interactions, and risk-based testing can also be used as a design technique. You focus your testing efforts on those areas of the software that pose the highest risk or have the biggest potential impact on the business.
Prioritizing those high-stakes areas.
Precisely. And then, of course, there are techniques for enhancing test coverage, making sure you're testing every nook and cranny of the software, and compliance validation techniques, ensuring the software meets all those regulatory requirements.
Now let's consider testing in complex ecosystems. In today's world, software is rarely isolated. It's interacting with other systems, APIs, cloud services, the whole shebang. How do you test effectively in such environments?
It's definitely a challenge. You're dealing with multiple technologies, different programming languages, different protocols. Often you need to adopt testing frameworks that can handle this diversity, and integration testing becomes absolutely paramount. You're testing those interactions, those data flows between all those different parts.
Making sure everything plays nicely together.
Exactly. And you have to watch out for compatibility issues, like when different frameworks or libraries clash, managing those third-party API dependencies, making sure they're reliable and you have backup plans if they're not. That's crucial. And then you have to think about backward compatibility, making sure your software still works with those older systems that might be out there.
It's a lot to juggle.
It is. And the document highlights the importance of proactive dependency management, data management, and configuration management in these complex ecosystems. You need clear documentation, version control, automation tools, and a lot of collaboration between teams. It's about staying organized and anticipating those potential points of failure.
Now let's look toward the future. What are some of the emerging trends in software testing that we need to be aware of?
Well, AI is definitely shaking things up. We're seeing AI-powered tools for test generation, automatically creating those test cases based on requirements or code analysis. AI can also analyze test results, spotting those subtle patterns and anomalies that we might miss. It can even help us prioritize our testing efforts, focusing on the areas most likely to have defects.
So AI is becoming our testing assistant.
In a way, yes. But it's not replacing human testers, it's augmenting our capabilities, allowing us to be more efficient and effective. And the document stresses that as testing professionals, we need to be constantly learning and adapting to keep up with these technological advancements. We need to master those new methodologies like Agile and DevOps. We need to hone our skills in test automation, data analysis, and AI. It's a rapidly evolving field.
Let's talk about lean and just-in-time testing. How do these approaches help us optimize and streamline the testing process?
Lean testing is all about eliminating waste, maximizing value. You're looking at your testing process as a whole, identifying those bottlenecks and inefficiencies. One technique is value stream mapping. You visualize the workflow and see where you can improve. Just-in-time testing is all about doing things in parallel with development. As developers are writing code, testers are already thinking about how to test it, providing that rapid feedback.
So testing becomes an integral part of the development process, not something that happens afterwards.
Precisely. And a big part of lean and just-in-time testing is eliminating waste. You're streamlining your test suites, automating those repetitive tasks, optimizing your test environments, and test data management. And prioritizing, focusing on those high-impact tests, the ones that provide the most value and mitigate the biggest risks. It's all about efficiency and delivering quality quickly.
And finally, we can't forget about the ethical considerations in software testing.
Absolutely. As software becomes more and more ingrained in our lives, we have a responsibility to ensure that it's not just functional, but also ethical.
What kind of ethical considerations are we talking about in testing?
Well, respecting user privacy is paramount. We need to get informed consent when we use user data for testing. We need to be transparent about how we're using that data. And we need to make sure it's protected, anonymized, and stored securely. Ensuring data security is crucial. Those robust encryption mechanisms, secure testing environments, and we need to be transparent with users about test results, especially when those results could impact their experience or their safety. We need to be aware of the potential consequences of flawed test results, financial losses, reputational damage, even safety hazards. And we need to be proactive in addressing bias, making sure our testing isn't discriminating against certain groups of users.
So ethics needs to be at the forefront of everything we do in testing.
Absolutely.
Well, this has been an incredibly deep dive into the world of software testing. We've covered a lot of ground, from those fundamental principles to those advanced techniques and emerging trends.
We've seen that software testing is far more than just finding bugs. It's a multifaceted discipline, a critical part of building high-quality software that we can all rely on.
For those listening, I hope you've gained a deeper appreciation for the complexity and importance of software testing.
We've given you a lot to think about. As we conclude, here's a final question to ponder. How do we balance the need for speed and innovation with the need for rigorous and ethical testing practices? In today's fast-paced world, how do we ensure that quality doesn't get sacrificed in the pursuit of rapid development?
It's a challenge we all face. Thanks for joining us on this deep dive. Until next time.